Good day, everyone. And before I move on, I would like to wish you all a happy new year, happy 2021. And I hope you have a better year in 2021 than you did in 2020. So let's move on to the next number theory problem in the series, problem 46. And it says, for each of the following primes P, it is known that 3 raised to the power n is congruent to 1 mod P, if and only if P minus 1 divides m. For which value of P does x cubed congruent to 3 mod P have an integer solution? And when they say for each of the following primes P, so they're talking of the primes in the options. Each of the numbers in the options are primes. And it is known that 3 raised by m is congruent to 1 mod P. So it means we don't have to test this. We just trust the examiner on this, okay? Okay, so, and a good thing about this, 3 raised to power m congruent to 1 mod P, which I wouldn't prove in this video, but you can try proving it on your own. If and only if P minus 1 divides m. It shows that for each modular residue in P, that's 1, 2, up to P minus 1. Each residue can be expressed, apart from 0, yeah? Apart from 0. Each residue can be expressed as a power of 3 mod P. So we're all dealing with numbers in mode 3. So we're just dealing with the set of integers. So I'll just put it. Okay, so 3x2. So each of these can be expressed as. Okay, so now it means we can apply that here. We can express this x as a power of 3. So let's say 3 to the power of k is congruent to x mod p. Okay, so it means that 3 to the power of 3k, when we cube both sides, is congruent to x cubed mod p. I want 3 to the power of 3k to be congruent to 3 mod p. So this is equivalent to, we can divide by 3 because the primes are different from 3 and hence they are relatively prime to 3. So this is equivalent to 3 to the power of 3k minus 1 congruent to 1 mod p. Okay. So what can we do from here? What can we do? One thing we can do is we can apply the statement in the problem that this happens if and only if P minus 1 divides the power. So we have P minus 1 divides the power 3k minus 1. 3k minus 1 is the power, okay? Now, suppose 3 divides P minus 1. That means 3 will have to divide the power 2. Okay? So we can just say, it implies that 3k minus 1 is congruent to 0 mod 3. And we're trying to get the contradiction from here. Since 3k is congruent to 0 mod 3, so it means minus 1 is congruent to 0 mod 3. So it means we have a contradiction. So it means 3 cannot divide P minus 1. Now I look at the options. 7 minus 1, we have so P minus 1, we'll just put P minus 1 here. So we have 6, we have 18, 30, 52, and 78. And we see that 3 divides each of these P minus 1s apart from option D. Okay, so it means our answer is going to be 53. But before we go on, let's get an integer solution for this in option D. Okay, so let's move on. Let's try to get. So we have x cubed. Want x cubed to be congruent to 3 mod 53. Okay, and so we got that 3 to the power 3k minus 1. So 3 to the power 3k minus 1 is congruent to 1 mod 53. Okay, so I'll just scroll down a bit here. So we've gotten an answer, but I want to just get some integer solutions for it. And so we have from the problem, it implies that p minus 1 divides 3k minus 1. And so we have 52 divides 3k minus 1. Okay. So, well, we just need the k that 52 divides 3k minus 1. So let's see if we equate 3k minus 1 to 52. Let's see if we can get okay. So this will become we'll get 3k equal to 53, and this doesn't work. So let's equate it to 2 times 52, which is 102. Sorry, 104. Okay, so we get 3k equal to 105, and this implies k equals to 105 over 3, which is equal to 35. So 35. Okay, so we see that if we replace x with 3 to the power of 35, okay, so the modular residue of 3 to the power of 35 mod 53 gives us an answer. Okay, so there are a lot of ways we can go about simplifying this. You can go the long method, but we have an integer solution to this modulo 53. So once the remainder, when 3 raised to the power of 35 is divided by 53, that remainder, it's is a simpler solution for it. But yeah, 3 raised to the power of 53, 3 raised to the power of 35 is also a solution to this. So we have our answer, option D. And so that'll be a good place to stop. And see you guys in the next video. Don't forget to like, comment, share, and subscribe. And keep solving maths. Goodbye, guys.